The next method is a factorial approach. First, we define a factorial. A factorial of a number is a product of the number and all the whole numbers less than that number. E.g., the factorial of 2 is equals to 2 by 1. 3 factorial is 3 by 2 by 1. 4 factorial is 4 by 3 by 2 by 1. Same for 5 factorial is 5 by 4 by 3 by 2 by 1. 0 and 1 are a special case because 0 factorial is 1, 1 factorial is also 1. If you are to flip this coin, there are only two possibilities that you can get, either a head this side or a tail. The probability of getting a head is a half. The probability of getting a tail is also a half. If you flip it 5 times, the 5 times will be n. If you flip it 3 times, the 3 times will be n. So let's take an example of n being equal to 3. If you flip the coin 3 times, what is the probability of getting 2 heads and 1 tail? The formula is n factorial multiplied by a b, whereby a is the probability of getting a head, b is the probability of getting a tail, to power x y, whereby x is the 2, y is the 1, over x factorial, y factorial. Coming back to a question, part A asks what is the chance that all the children will be unaffected? Probability all children unaffected will be equal to n factorial a b x y all over x factorial y factorial is equals to n is 5 because we have 5 children. 5 factorial a, we are using our probabilities here, u and a, 3 out of 4 and 1 out of 4. So u, we know u is 3 out of 4, a is equals to 1 out of 4, n is equals to 5. So 5 factorial 3 out of 4 to power all children being unaffected is 5. Then 1 over 4 to power 0 all over 5 factorial, this power here, multiplied by 0 factorial is equals to, you write out the number 5 by 4 by 3 by 2 by 1 over 5 by 4 by 3 by 2 by 1. This is 5 factorial, this one here, this one is 5 factorial, and then multiplied by 0 factorial, which is 1, multiplied by 3 over 4 to power 5, multiplied by 1 over 4 to power 0. This goes with this, so that you get is equals to 3 out of 4 to power 5, which gives us the same answer, 243 over 1024. Part B, what is the chance that 4 children will be unaffected and 1 affected? The same thing, probability of 4 children being unaffected, 4 unaffected, and 1 affected is equals to n factorial over x factorial y factorial a b x y is equals to 5 factorial 3 over 4 1 over 4 x y. We've been told 4 unaffected, so to power 4 to power 1 all over 4 factorial 1 factorial. We multiply out 5 by 4 by 3 by 2 by 1 over 4 by 3 by 2 by 1 multiplied by 1 by 1. This is 1 factorial, this is 4 factorial, multiplied by 3 over 4 to power 4 multiplied by 1 over 4 to power 1. This goes with this, and the answer comes back to 405 to power 1024. Same thing as here. Part C, probability of at least 3 children being unaffected. At least 3 unaffected. will be equal to probability of 3 being unaffected or 4 being unaffected or 5 being unaffected, which is equal to, we already have this one here in this one. So first get the probability of 3 being unaffected, which is n factorial a b to power x power y all over this power factorial x factorial y factorial is equals to 5 factorial 3 over 4 to power 3 unaffected 3 b to power 1 over 4 squared all over 3 factorial 2 factorial is equals to 5 by 4 by 3 by 2 by 1, that is 5 factorial all over 3 factorial, which is 3 by 2 by 1, multiplied by 2 factorial, which is 2 by 1, then multiplied by 3 over 4 to power 3, multiplied by 1 over 4 squared. It gives you, this cancels with this, by 2 1 by 2 2. This one gives you 270 over 1024. This is the probability of 3 being unaffected. You add to the probability of 4 and 5, which is this and this. So the answer is 270 over 1024 plus 243 over 1024 plus 405 over 1024 gives you 918 all over 1024. Part D remains the same as part D here. So part D, probability of having an unaffected girl is equals to probability of being unaffected multiplied by probability of being a girl. This is 3 over 4 multiplied by 1 over 2, which is 3 out of 8.